Okay, this is the graph of f of x equals 1/4 x squared. Now, what I would like to do is take this graph and calculate the area underneath it. And that would be all of this region down here. And again, I'm not going to, all of it between the x-axis and under the curve. So instead of shading every bit of it, we get the idea. This area here. Now, the problem I run into is I'm dealing with a curve. And estimating an area of a curve can be very difficult. So what I would like to do is use a different shape that is much easier to take the area of. And in calculus, the easiest shape that we can think of is going to be a rectangle. So notice, I come out down here and I can divide this object into 4 rectangles. Pretty easy. And if I want to find the area of a rectangle, it's just going to be its width times its length. So just take a look at this one rectangle at the end here. That's pretty easy. The width is 1. And notice that this particular rectangle connects on what it's called its right-hand side. So a rectangle has 2 sides, its left side, its right side, and this rectangle touches the function on its right side. So what's convenient about it, since it's touching the function on its right side, that tells me how tall or how high this goes here, which I need to know to calculate the area. I can get this directly from the formula, and in this case, the x value is 4. I can find that height, again, just by using the formula, using the x value. In this case, I have 1/4 times x squared, which is 4. So what do we have? 1/4, 4 squared is 16, and times 1/4 is 4. So this rectangle has a width of 1 and a height of 4, so the area of this one rectangle is 4. And I can do this for each one of my rectangles, one at a time, and add them together. The problem is that it's too big. All of this region up here is extra area, and that's more than I was trying to calculate. So using this technique, all of this extra area will be included in my estimate, and so my estimate won't be the best. So the question becomes, how can I make my estimate better? One technique, and the one that we're going to be examining the most, is have more rectangles. What I'd like you to notice is my original first rectangle looked like this and had all of this area. And my second original rectangle looked like this, and this one looked like this, and of course my fourth original rectangle looked like this. But by going to 8 rectangles, what I have done is basically remove all of this extra area. So now each rectangle is more narrow, and each rectangle has less wasted area. So here are my 8 rectangles. And that's what I want you to notice. My estimate now is going to become better and better. And for each rectangle, I can calculate its width. So I have 8 rectangles, each one has a width of 1/2. And each one has a length or a height. And again, because the function touches the rectangle on its right-hand side, I can calculate that using the formula for the function. And again, this function is 1/4 x squared. And I'm not going to go through the process just yet because I'm just giving you the big idea right now. But the big idea here is more rectangles, more accurate. So ultimately, what we would like to do is see how many rectangles is practical. That's one technique. So here I am in Desmos with my graph. And again, this slider here controls the number of rectangles. I have 8 rectangles. And look closely at the graph as I produce more rectangles. Notice there's less extra on top. So my estimate's getting better and better as I have more and more rectangles because my overestimate is becoming smaller and smaller. And once I hit 100 rectangles, that might be a lot of work to do, but my estimate is extraordinarily useful here. So that's one thing that we control, more and more rectangles. But that's not the only thing we can control. So I'm going to go back to 8 rectangles. These rectangles, as you should notice, all of them are touching on the right-hand side. We talked about that earlier. So because they're all touching on the right-hand side, they're each a little bit too big. I can control that, and I can connect them instead of on the right-hand side. I can look at all of these 8 rectangles, and I can look at all of these 8 rectangles which are connected on the left-hand side. So notice, since it's on the left-hand side, each one of these rectangles is too small. So I can calculate the area of these 8 rectangles. It's going to be too low on the left-hand side, and I can calculate the ones on the right-hand side. It's going to be too high. And I'm guessing if I took the average of the two, it would be very, very close and a very reasonable estimate. So I'm going to do that next video. But again, the idea here that I want you to take away is I can divide my object into rectangles to estimate the area under a curve. More rectangles will give me a more accurate estimate. Looking at left-hand rectangles and right-hand rectangles and comparing the two will even give me a better estimate. And on my next video, we'll actually do the calculations.